welcome back to Algebra 2, Day 2 of 5.1. Today we're going to be evaluating expressions with rational exponents and also taking a look at using nth roots to solve equations by rewriting those expressions using properties of exponents. So first of all, last week we simplified radical expressions assuming that all variables were positive numbers. And today we're going to look at what happens if they could be negative numbers, okay? So we run into a problem here because if this could be any negative integers, we run into a problem when we're solving these. If we have an even index here, like a square root or a fourth root or a sixth root, any kind of even index with even powers, and it simplifies to an odd power on the outside. Here's what happens. Let's just assume that x is -1, and so we end up with the square root of -1 to the 14th power. Well, that will simplify to the square root of -1 to the 14th power is a positive 1, right? And that ends up being just 1, okay? Well, it simplifies out here to x to the 7th power. So if we substitute -1 out here, after it's simplified, that would become -1 to the 7th power. Well, a -1 to the 7th power ends up being a -1. And so a positive 1 is not equivalent to a -1. So to ensure that stays positive, we have to always wrap a absolute value around that guy to make sure that stays a positive 1. Okay. Now this only occurs, again, if we have an even index with even powers and it comes out to an odd power after you simplify. If it has an even index here and it simplifies to an even out here, it doesn't matter, because a negative number here simplified is going to become positive because of the nature of the positive power. Any negative number to a positive power is going to result in a positive number, okay? So again, down here, any even out to an odd. Those are the ones you have to worry about. If it's an odd roots at all, you don't even have to worry about it, okay? Just watch our even roots. So let's go ahead and simplify these guys, and we'll kind of watch for these. This has an odd root here, so we're not even going to have to worry about it. Okay, so we just take the 5th root of 32, which is 2. The 5th root of m to the 15th. Remember, we just take our power, divide by our index. So m15 divided by 5 leaves me with m to the 3rd power, and that is simplified. Okay. Then we're going to look at this guy. Now this guy, we should have a little bit of eyebrows raised here because we have an even root and we have 2 even powers, okay? And so I'm a little bit concerned there, so I want to make sure we raise a little bit of a red flag on that one and watch out when we're finished simplifying, see if we have any odd powers after we're done simplifying. So we have x, the 20 divided by 4 leaves us with a 5th power. Y to the 8 divided by 2 leaves us with the 2nd power. And then because this is an odd power after we simplify, we have to make sure that stays positive by wrapping that guy in an absolute value, and that will be simplified. Absolute value of x to the 5th times y squared, okay? If it ever says that you just assume all variables are positive, then we don't need to worry about the absolute values. But if we don't assume the variables are all positive, we have to watch those absolute values. Okay, so you might want to try these on your own here. Come back and see how we do, okay? So this first one here, this is a cube function. It's odd, so we don't have to worry about any absolute values. The cube root of -8 is -2. The 3rd power divided by a 3rd index is just a to the 1st power. And then b to the 9th power divided by 3 gives me b cubed. And that is our simplified expression. Okay, my second one here, we do have an even root here, an even index. So we want to make sure that we watch out for that guy. Okay, and so if we simplify this guy, what's the 4th root of 256? Now, if you don't know that right off the top of your head, we can go ahead and look at our calculator here, and we're going to go 256, and we're going to use this. Sometimes you guys might have the caret button. Sometimes you might have this x to the y function. Put it in parentheses. 1 divided by 4, so that tells me it's in the power of 1/4, okay, which is 4. All right, so we know that the 4th root of 256 is 4, which means 4 times 4 times 4 times 4 is 256, okay. X to the 12 divided by 4 is x cubed, y to the 24 divided by 4 is to the 6th power. And we do have an odd power here, so we have to make sure we wrap that guy in absolute values. And then we will have our simplified expression for absolute value of x cubed times y to the 6th. Okay? Okay, so our next concept is solving. To solve an equation in the form of x to some power n equals a constant, find the nth root of both sides by raising each power to 1 over nth, so like the reciprocal of n. Okay, it'll make more sense when we do it here. So if we have this equation here, 2 times x to the 5th equals 64. Just like every equation, the very first thing we want to do is isolate the variable. Okay, so divide each side by 2. So x to the 5th equals 64 divided by 2 gives me 32. Okay, so now what we want to do here is we're going to raise both sides to the reciprocal of the 5th power, which is 1/5. Raise both sides to the 1/5 power. Okay, we could take the 5th root, but we're going to kind of put this method to use a little bit later. So kind of practice using this 1/5 power. That's going to be x to the, and the 1/5 root, 1/5 power of 32 is 2. Okay. And then this guy here, once again, we're going to make sure we isolate that variable first. So p to the 4th power equals 81. And then we're going to go ahead and raise both sides to 1/4, the reciprocal of that guy. Okay. And so now 4 times 1/4 is p to the 1st power. And then the 4th root, and here's the kicker here. This is an even root. Okay. So remember, whenever we take an even root, we have to take the positive and negative solution. Okay. This is going to be positive and negative 3. Okay. The 4th root of 81 is 3. So it's positive and negative 3. So anytime you haven't taken an even root of any number, doesn't matter. We have to make sure we take the positive and negative solution. Just like you take a square root, 4th root, it's positive and negative. All right. Okay, so now let's look at an application here. All right, we have one cube-shaped container that has an edge length of 2 centimeters longer than the edge length of a second cube. The volume of the larger cube is 729. When the larger cube empties in the smaller cube, how much water will spill? So first of all, let's go volume of the larger cube and the volume of the smaller cube here. Okay, so my volume of my larger one is 2 centimeters longer. So my edge is x plus 2, and my volume, my edge length over here is x. Okay, well, my volume is the length times the width times the height. So I'm just going to take basically x plus 2 times x plus 2 times x plus 2, which is going to give me x cubed, and that's going to be 729. Okay, so to solve for that, we're going to raise both sides to the 1/3 power. Right? It's reciprocal, 1/3. 1/3 power here. Okay, so that's going to give me now x plus 2 equals, and now let's go ahead and take a look at our calculator here, and let's see what the cube root of 729 is. We go 729, and we're going to put x to the y power. We're going to take 1/3. 1 divided by 3, that tells me 1/3 root, and that is 9. Okay, so 9 times 9 times 9 is 729. And then I can subtract 2 from each side, and x equals 7. Okay, so if x equals 7, that means that up here, x equals 7. Okay, so the volume of my smaller cube then is x cubed equals the volume of my second cube here. So 7 cubed is what is that? 7 times 7 is 49. Let's go 7 to the 3rd power, which is 343. All right, so the volume of my smaller one is 343. Now they want to know how much water is going to spill out. So basically we're going to take that 729 and subtract the volume of my smaller cube, 343. And what does that give us? We're going to get 6. Let's see, I just go. I don't want to do that math in my head right now. It's too late. So let's just take the 729. 729, and we're just going to subtract that 343. and it's going to give us 386. Okay, 386 cubic centimeters will spill out everywhere when they take the big one and put it into the small one. Okay. Okay, so that is my concept summary right here. This kind of simplifies my radicals and how to solve using our reciprocals. Over here is kind of my volumes, I guess. And then you have an Excel in Google Classroom, and I will see you all at our next Zoom or in person, whatever comes first. Thanks so much. Bye-bye.